I am Kaveh Shahedi and I'm a machine learning intern at Ericsson with the Trace Compass team. In this video, I'm going to introduce you to the TSP Python Client, a Python-based wrapper for communicating with the Trace server that allows you to open your traces, open experiment, get the outputs, get the data using either the command line or the Python code. So basically, for using the TSP Python Client, you need to first install the Trace server in your machine and running it. Opening the TSP Python client, the first link that you see is a Trace Server protocol. So if you open that, you can come down and see the Trace Server download link. Based on your platform, you go ahead and download it. And after downloading that, you can see have this file structure. By double clicking on the Trace Compass server, it will pop up. And be careful that you need to install JDK 17 in your machine for properly running it. Coming back to the TSP Python client, go ahead and clone this in your machine. And you can see this file structure again. So everything that we do will go through the TSP Python client, TSP CLI client. So in this part, we are going to cover the command line. So go ahead and open a command line in this directory. I have already done that, and you can see the files here. One of the things that you first need to do is install the requirements since it's a Python module. So we can go ahead and say pip3 install requirements. But the thing is that since we are not using any virtual environments, the installation may have conflict with your already installed dependencies in your machine. So a safe way to do is like create a first virtual environment. We say Python 3, we create a virtual environment with the name of, again, same that, and then we activate it. So we say, so we activate it. As you can see, we are in the virtual environment, and then we say pip3 install requirements. It will go ahead and find all the dependencies that are required by the TSP Python client, and it will install it. So everything that we need to do is going through the TSP CLI client. So if we use that, we can see all the possible options that we can have. But the easier case, if you check the repository page, there is an example at the end of the page, which is like 90% of the things that you want can be done through here. So for instance, if you want to open a trace, you just say TSP CLI client, like open trace, and then you define the path to the trace. So in my case, it's like app data xz52 and then kernel, and with the name of xz kernel. So as you can see, it will go and open it. So we need to like have this UUID because everything that we do through the TSP Python client is gonna be through the UUIDs or IDs, not names, not paths, only the IDs or UUIDs. So imagine that I want to like create an experiment for this. Again, I say TSP CLI client, open experiment. With what name? Like xz experiment, and like which traces. So I need to copy and paste all the UUIDs of traces that I have. So if I have like 10 traces, I need to copy and paste all of them back to back. So it will go ahead and open this experiment for me. So as you can see, it's running. So it will load all the trace files. And then once it's completed, we can go ahead and get the output that we want. So since here, I only need to access to the UUID of the experiment. So since the trace file is not that big, I'm sure that it's already completed, but for making sure, we can say TSP CLI client list experiments. So as you can see, this experiment, xz experiment, is already completed, and this is the trace that belongs to this experiment. Now I want to like get the outputs of this. I say list outputs. So as you can see, this experiment can access to like different outputs like the memory usage, the interrupts, the histogram, the futexes, the events table, the CPU usage, and disk IO view. Now consider that we want to like get the data for one of these outputs like the events table. Again, I mentioned we only work with the IDs, UUIDs, not the names, not anything. So we need to like copy and paste. What happened here? So coming back, what was there giving? Okay, the events table. We need to copy and paste this. Copy this, and then instead of like saying list outputs, I want to like so since it's a table, first we need to get the data. First we need to get the tree. So we say get tree for what output? For this output. For which UUID? For this UUID. So if we say that, we can say that. So in this table we have like the timestamp, channel, CPU, event type, and until the end. So how we can actually get the data of this table? So based on the documentation of this example here, for getting the tree is like get tree as we covered, and for get the data, actual data, we can go ahead and say get virtual table lines. Okay, so again we say, so instead of get the tree, get virtual table lines. So if we say that, it says either table line index, from which row you want the data, or between which times you want the data. So I want to say table line index, so since the very beginning, and for how many table line count for 10 rows. So if I say that, we can see all of the data has been returned. So this is like the first cell. So the first this is the first row, and the first cell is the timestamp, the second one is the channel, then the CPU, and then the event type. So all of these come from this timestamp, channel, CPU, and these are the IDs. So consider that I only want the timestamp, channel, and the CPU. I say table column IDs 0, 1, and 2. So now it will return only the timestamp, channel, and the CPU. So for finding another examples, for getting another types of data like the XY, the time graphs, you can come and check out the example in the end of this repository page in the README file. I hope that you have enjoyed this video, and if you have any questions, feel free to contact the Trace Compass team. Have a nice day.